Hello. So first we should start with some of the first principles of the basic theories of hydraulics. It's really good to understand the fundamentals, helps you appreciate how other things, get a feel for how other things work. Just the really simple principles these are. And the first one is that if you have a pressure at this point in a fluid, we've got our fluid in our pipework, you'll have the same pressure at this point in the fluid. So essentially, no matter how many pipes or bends or you have in your system, you can transmit the pressure and the power through the pipework, which is fundamentally why people use hydraulics. It's very high power density, can be transmitted flexibly to any locations and distributed in different ways. So it's a very versatile technology. We can also see here that if we've got a small cylinder area and a small mass, we get the same pressure, because this is balanced, as a big cylinder and a big mass. If we were to put the small mass onto here, so we had the same masses with different areas, then the smaller cylinder would generate a higher pressure and this larger cylinder would rise. So that's essentially all you need to know. Hydraulics is not that tricky with its principles. One of the interesting things, we always have conservation of energy. That's just a fact of life. Hydraulics is a braking technology, so we tend to use orifices and restrictors to slow the movements down. That means we keep them in control. But conservation of energy says that if we have a pressure and a flow here, we have an energy loss through an orifice, we must get heat. So we can generate quite a lot of heat in hydraulics. Clearly, that's one thing we try and keep down, but when we are controlling, we do use the principles of braking a lot in hydraulics. One of the other issues doesn't come up much because we don't use trap volumes, but you will get basic Boyle's law, P1 T1 over V1 equals P2 T2 over V2. So basically, if we change the temperature in this one and we allow the movement, then the volume will increase. Only very small, but it is significant. If we were to if we had a sealed volume or put a bigger weight on here, we get an extra pressure. So if the temperature goes up, the pressure goes up as well. That's one of the big risks why we don't have trapped in volumes, because they can cause issues in high pressures very quickly. The other thing to note, one of the principles that is not well understood, we always assume, or initially assume, that fluid is incompressible, which would mean that if you hit that with a hammer or you put extra mass on it, the volume would stay the same. Now in basic theory, fluid is virtually incompressible, so a lot of the time we can assume that. If you're working with servo valves, higher performance valves, you do need to check this, because essentially if you do hit that with a hammer or put a larger mass on there, the volume will change and it will oscillate. It does work like a spring, but that's only important when we're looking at servo proportional and the higher performance systems. So for the most part, fluid is incompressible, and as you saw on the first slide, if you move it one place, it will move the same distance, same volume in another place. So very simple basic theories, lots more to come.